Today we're doing section 1.7 day 3, and we're going to be talking about the composition of functions. So here's our two functions, f of x and g of x. F of x is equal to 3x minus 4, and g of x is equal to x squared minus 2x. So the first thing that we're going to do is f of g of x, and again, this is something we went over last year. The way we pronounce this is f of g of x, and this means that I'm going to input g into the f function. So basically I'm evaluating the f function at x squared minus 2x. So everywhere I see x in f of x function, I'll replace it with that. So in the f function, I have 3 times the quantity of x squared minus 2x. And I distribute the 3, and I get 3x squared minus 6x minus 4. And that's our final answer. Now the second one is g of f of x, so that this means into the g function I am plugging f. So everywhere I see x in the g function, I'll input the f function. So this one's a little bit more involved. Remember, when something's squared, that means there's 2 of them. So this means I have a 3x minus 4 times a 3x minus 4. So those of you who FOIL or box, you're going to have to find this quantity. So I would get a 9x squared. My inner and outer terms are both going to be 12x, so I could just say minus 24x and then plus 16. And now I distribute both terms over here. I'll get minus 6x plus 8. And now I combine like terms, so these can combine and those two can combine. So I get 9x squared minus 30x plus 24. So notice you get two very different answers of doing f of g of x versus g of f of x. So it is important to understand the difference between the two. So the next example we're going to discuss is our domain. So, I lied, we have one more for this problem. So this means I need to evaluate the function g at 1, and then whatever I get, I plug it into the f function. So g of 1, our g function, is x squared minus, 2 times x. So 1 squared is 1 minus 2 is negative 1. So now I go back to this problem, and where I see g of 1, I replace it with negative 1. Now I'm evaluating f at negative 1. So I have 3 times negative 1 minus 4. Negative 3 minus 4 is negative 7. So that's our final answer. The next one we're going to evaluate, and then we'll discuss how to find the domain. So here we have f of x is 2 over x minus 1, and g of x is 3 over x. So we're just going to find f of g of x, and then we'll discuss the domain. So I'm going to, essentially I'm evaluating the f function at 3 over x. So I have 2 over this 3 over x minus 1. So we need to simplify this a little bit. I want to get common denominators in the bottom. So I'm going to change this 1 to be x over x. So remember, it's like I'm timesing by x over x. So now I'm at 2 over 3 minus x over x. And then we know that we need to keep change flip. So I keep the top of 2 over 1 times x over 3 minus x. Multiply straight through top and bottom. We get 2x over 3 minus x. So the most important thing here is the rule for the domain. So the domain issue states if a value is restricted in G, so if it's restricted in G, then it's also restricted in f of g of x. So basically you need to determine what value cannot be in the g function, and that also needs to be a restricted value. So I'm actually going to erase all this work off to the side so I have more room on this slide to do our domain. So again, you can always rewind the video if you didn't get a chance to copy down the process there. So I'm looking at my g function, and in my g function I have 3 over x, so this is an issue. So from this I'll say x cannot equal 0. And then I need to go to the actual problem itself, so I'm going to go back to this original problem, and again 3 minus x cannot equal 0. I'll add that x over, so x cannot equal 3 as well. So our domain is going to be from negative infinity to 0, union 0 to 3, union 3 to infinity. So the reason I didn't really discuss it in the last problem is neither one of those had fractions or square roots, so we didn't really need to talk about it. So the domain would have been negative infinity to infinity. So one last problem, and it's kind of like an abstract type of problem, so I forgot to label this. So the blue one is our g of x function, and the red one is our f of x function. So we're going to use the picture. This is a different way to write it, so notice they put f plus g of 1. So this means essentially I'm going to find f of 1 and g of 1, and then I'm adding those results together. It's just a different way to write it. So when x is 1 in the f function, my y is 1. When x is 1 in the g function, sorry, negative 1, when g is 1, the y value is positive 1. So when I add these two results, I get 0. So it's just, you're obtaining the information graphically. In the next one, we're doing the composition. So it's what we did today. We're just going to do it without a function. So g of 2, I need to find that first. So I go over when x is 2, my y value for that is 0. So that means g of 2 is 0. And now, because my output is 0, I'm now evaluating f at 0. So when x is 0, my y value is negative 2. So the final answer is negative 2. So different way to go about it, just graphically, but same idea. So this is all for today. We'll pick up with this tomorrow.